Hi folks, we're going to take a look at number 4 from the unit assignment. All right, so here they're asking us to solve this equation over the interval negative 2 pi to 2 pi. Okay, so let's take a look at what we have. And when you first look at this here, you might actually, sorry about that, you might actually think that you might be able to factor that because you see a square here, a square there, 2 sine. This kind of looks a lot like x squared plus 2xy plus y squared, or minus 2xy plus y squared. And the problem is this subtraction here. So it's not going to work out, because if you try to set that up, you're going to see that this should end up being a plus sine squared. So we won't be able to factor here. So we're going to have to look for some other solution. Okay, and hopefully you might take a look at this middle term and say, well, hey, that kind of looks familiar because that looks a lot like sine of 2x. Okay. Now, on its own, not so interesting until I look at the other two terms, cos squared x minus sine squared x, and you realize, hey, that's equal to cos of 2x. So I can rewrite this left-hand side as cos of 2x minus sine of 2x. Now, what's nice about this, first of all, is that they're trig ratios with the same input, all right? And what we can now do is we can bring that minus sine 2x to the other side, and we end up with cos 2x equals sine 2x. Okay. Now, while we certainly could divide both sides by cos 2x to get tan 2x equals 1, okay, and that would be a perfectly good way to go. Because I can actually avoid doing that, I always try to do that, because when I divide both sides by cos of 2x, I'm eliminating any solutions that might make cos of 2x equal to 0. Okay, now in this case here, those won't result in any solutions. But if I can avoid dividing both sides by some expression that contains a variable, I certainly do. And in this case, we can, because we know when sine x and cos x are going to be equal to each other. We know that that happens at pi over 4 in the first quadrant, where our x and y values are exactly the same. And it's also going to happen in the third quadrant, where again, for any point along this terminal arm, the x and y values are going to be the same. All right, so here we know that in this case here, our input is not x but 2x. That 2x can be equal to pi over 4 or 5 pi over 4. Okay, sorry, I think I said 3 pi over 4 before. I meant 5 pi over 4 in the third quadrant. And so now we've got our two answers in the first cycle, and so now we can solve for x. So x is equal to pi over 8, or x is equal to 5 pi over 8. And now to generate other solutions, I can just add and subtract the period as needed. So in this case here, I'm working with cos and sine of 2x. So the period is not 2 pi, it's 2 pi over the k value, which is 2. So the period is actually pi. So I'm just going to be adding and subtracting pi as needed. Okay, but of course, I'm not going to think of it as pi. I'm going to think of it as 8 pi over 8 so that I can easily do my additions. Okay, so I can go as far as 2 pi, which is 16 pi over 8. So here, if I add 8 pi over 8, I get 9 pi over 8. So that's perfectly fine. But if I add another 8, I get 17 pi over 8. That's too big. So now let's start subtracting 8 pi over 8. So pi over 8 minus 8 pi over 8 is negative 7 pi over 8. If I subtract another 8, that gives me negative 15 pi over 8. That is still good. Nope, over 8, because negative 2 pi is negative 16 pi over 8. Okay, but I can't go any further, or otherwise I'll be below. Do the same thing on this side. Let's add 8 pi over 8, so 13 pi over 8. But if I try to go any further, I'll be beyond 2 pi. So let's subtract now. 5 minus 8 is negative 3 pi over 8. That's good. Subtract another 8, negative 11 pi over 8. That's still good. But if I subtract another 8, I'm going to be beyond negative 2 pi. And so here we've got 8 answers to solve this equation. All right, so just to recap here, step number 1, a good thing to try to look at if there's any algebra we can do. Because that didn't work, we hopefully recognize that this expression and these two expressions relate to our double angle formulas, and from there we're able to solve it. Okay, that's it for this one.